Hello everyone, today we'll talk about the problem find the minimum and maximum number of nodes between critical points. This is a linked list problem. We're interested in local maxima and local minima. We treat both of them as critical points. And we only want to return the shortest and the longest distance between any two distinct critical points, so any two distinct local extrema in our linked list. So, while this is a linked list problem, there isn't much of the typical linked list problems when solving this problem, because we can simply traverse this linked list a single time, look at appropriate vertices at each point, at appropriate nodes, because we just need to look at 3 consecutive nodes at any given point, and see if the middle one is either greater than the side ones or smaller than the side ones, and also maintain some counter to know, for instance, where the last critical point was, when the first critical point was, and so on. And based on that, we can calculate our result. So let's see the implementation. We'll have to remember both our answer, so the shortest distance between two and farthest distance between two critical points. And also we have to just remember the position. So we'll be going through incrementing our position, which is in the variable I. We'll remember the position of the first critical point and the last critical point that we've seen up to now. So here I'll just showcase that I'll be assigning none to all those values at the beginning to check if they have been assigned to or not. In other languages, or if it's your preference, you might also, for instance, for last put something like -1, or for first put something like 1,000,000. But in Python you can also use none. And now we'll go through the whole linked list, and we'll look at the value that we're looking at, the next value, and the next value of that next value. So those are 3 consecutive nodes in our linked list. And we require the last of those 3 to still be a node. After each step, we just progress once to the right. We have to check if the position head.next is a critical point. One way to do that is to calculate the difference between it and both its neighbors. And those differences have to be non-zero and have the same sign. And to check that they have the same sign and are non-zero, we can just multiply them together. So this multiplication is greater than 0 exactly when this head.next is a local maximum or a local minimum. And now we just have to use our variables, adjust them. So if this is the first critical point, we remember that this is the position of the first critical point. Otherwise, we update our maximum distance to be the distance from the first point to where we are now. And so if there was any previous point, then again, we either calculate the distance from this point to the previous point to be our current minimum distance, or we take the previous minimum distance, we take the distance from the current critical point to the previous critical point, we take the minimum of those, and that is now the new minimum distance between any two critical points. And of course we remember that the last critical point we've seen was at position I. And we're also being told that we have to return -1, -1 if we haven't found more than one critical point. So we do that, otherwise we return the calculated values.